ठीक है, आवाज आ रही है। अब देखो नोट 1 परम्यूटेशन में क्या है। इफ f is equal to a1 a2 a3 so on an, b1 b2 b3 so on bn, ये जो b1 b2 b3 so on bn है, दिस इज ए रीअरेंजमेंट ऑफ दीज एलिमेंट्स। इनमें से कोई होगा जो ऊपर के एलिमेंट्स के बराबर है, बट ऑल ऑफ देम आर डिफरेंट। बी ए परम्यूटेशन ऑफ डिग्री n, then the inverse of f, that is f inverse, is obtained by interchanging the rows of f। खाली रोज को ऊपर नीचे कर देना है। thus f inverse is equal to b1 b2 b3 so on bn and a1 a2 a3 so on an। so this will be your inverse of f। note 2, if we are to write the set of all permutations of degree n, it is immaterial whatever symbols we use to denote the elements of the set S। हम कोई भी सिंबल यूज कर सकते हैं। We can use the numbers 1 2 3 so on n, or we can use the letters a1 a2 a3 so on n or any other symbols। note 3 देखो, the group Pn of all permutations of degree n is called the symmetric group of degree n or the symmetric group of order factorial n। इसके बाद आ जाता है तुम लोग का साइक्लिक परम्यूटेशन क्या है। देखो डेफिनेशन, सपोज f is a permutation of degree n on a set S having n distinct elements। let it be possible to arrange m elements of the set S, m elements n m क्या है, n छोटा है, in a row in such a way that the f image of each element in the row is the element which follows it। the f image of the last element is the first element। ये m फर्स्ट टर्म एलिमेंट्स के लिए है। and the remaining n minus m elements of the set are left unchanged by f। बाकी जो n minus m elements बच रहे हैं वो उनमें कोई भी चेंज नहीं हो रहा। यानी अगर am+1 है तो am+1 को ही जा रहा है। am+1 goes to am+1 and so on। then f is called a cyclic permutation or a cycle of length m or an m cycle, क्योंकि जो फर्स्ट m एलिमेंट्स हैं उन्हीं में चेंज हो रहा है, रेस्ट n माइनस m एलिमेंट्स में कोई चेंज नहीं। by the length of a cycle we mean the number of objects permuted by the cycle। एग्जाम्पल से क्लियर हो जाएगा क्या है ये। फॉर एग्जाम्पल द परम्यूटेशन f is equal to 1 2 5 3 6 4 2 4 5 1 6 3। देखो यहाँ 1 goes to 2 है, 2 goes to 4 4 goes to 3 3 goes to 1। तो यहाँ पर जो 1 है ये अगेन 1 पे आ गया। तो 4 एलिमेंट्स है, 5 goes to 5 and 6 goes to 6। this 5 and 6, these two elements are left unchanged, means first 4 elements are written in this way। so this is a cycle of 4 or 4 cycle, you can say it is a 4 cycle or cycle of length 4। it can be represented by the cycle 1 2 4 3, which means that each element in the bracket is replaced by the element following it। यानी कि 1 goes to 2 2 goes to 4 4 goes to 3 and 3 again goes to 1। that the last element is replaced by the first element and the missing elements 5 and 6 they are left unchanged। तो 5 और 6 में कोई चेंज नहीं है। thus 1 is replaced by 2 2 by 4 4 by 3 3 by 1 5 by 5 and 6 by 6। the length of this cycle is 4। similarly the permutation g is equal to 1 goes to 2 2 goes to 3 3 goes to 4 4 goes to 5 5 goes to 6 and 6 goes to 1। तो ये क्या हो जाएगा, लेंथ 6 का हो गया। इस साइक्लिक we can write it in the form of the cycle 1 2 3 4 5 6, which is of length 6। however the permutation h 1 goes to 2 2 goes to 1 4 goes to 3 3 goes to 4 5 goes to 5 6 goes to 6, it is not cyclic because here देखो एक साइकिल ये बन रहा है, एक साइकिल ये बन गया है, तो इट इज नॉट साइक्लिक। नेक्स्ट, परम्यूटेशंस represented by a cycle। if 1 through 3 4 to 6 is a cycle of length 5, suppose it represents a permutation of degree 9 on a set S consisting of the elements 1 2 3 5 6 7 8 9। then the permutation represented will be only these three elements are permuted, rest are left unchanged. So 1, 2, 3, 4 to 6, 5 goes to 5, 7 goes to 7, 8 goes to 8, 9 goes to 9, and here 1 goes to 3, 3, 4, 4 to 2, 6, and 6, 1. So it is a cycle of length 5. It represents a permutation of degree 9. Rest 4 elements are left unchanged. That is the image of each element in the cycle 1, 3, 4, 2, 6 is the element which follows it. The image of the last element 6 is the first element 1, and the missing elements 5, 7, 8, 9 they are their images themselves. तो इनमें कोई चेंज नहीं है कि और इन्हीं में चेंज है, तो ये हो जाएगा साइकिल ऑफ लेंथ 5. However, if the cycle 1, 3, 4, 2, 6 represents a permutation of degree 6 on 6 elements, 1, 2, 3, 4, 5, 6, then the corresponding permutation will be 1, 3, 4, 2, 6, 3, 4, 2, 6, 1, and 5 goes to 5. So यहाँ पे भी this is also of length 5, but there are six symbols. Therefore, this left symbol 5 is replaced by itself. So this is your permutations represented by a cycle. अब देखो important note क्या कहता है. A cycle does not change by changing the places of its elements, provided their cyclic order is not changed. अगर cyclic order को change नहीं कर रहे हैं तो cycle में कोई change नहीं. जैसे 1, 2, 3, 4 is equal to 2, 3, 4, 1. दोनों 4 लेंथ का है और साइक्लिक ऑर्डर को चेंज नहीं किया. 2, 3, 4, 1, 3, 4, 1, 2, 4, 1, 2, 3, एंड ऑल्सो 1, 2 is equal to 2, 1, 2, 3 is equal to 3, 2. साइक्लिक ऑर्डर को चेंज नहीं करना, तो साइकिल में कोई चेंज नहीं होगा. नेक्स्ट, देयर इज ए कॉन्सेप्ट ऑफ ट्रांसपोजिशंस. देखो उसका डेफिनेशन. A cycle of length 2 is called a transposition. So this is your transposition, this is transposition, this is transposition, and again this is also a transposition. A cycle of length 2. Thus the cycle 1, 3 is a transposition. It will represent a permutation in which the image of 1 is 3, the image of 3 is 1, and the remaining missing elements are left unchanged. कोई change नहीं. If the transposition 2, 3 is a permutation of degree 3 on 3 symbols 1, 2, 3. देखो खाली 2, 3 में change हो रहा है तो 1 will be left unchanged. Then the corresponding permutation will be, क्या हो जाएगा permutation उसके लिए? 1, 2, 3, 1, 3, 2. 2 goes to 3, 3 goes to 2, and 1 is left unchanged. So this is also a cycle of length 2. A cycle of length 1 means that the image of the element involved is the element itself, and the missing elements are left unchanged. Thus all the elements are left unchanged. ठीक है. Image of the element involved is the image element itself, खुद ही हो जाएगा, और बाकी एलिमेंट अनचेंज हैं. इसका मतलब सभी एलिमेंट अनचेंज हो गए. Therefore every cycle of length 1 will represent the identity permutation. और इसके बाद आता है आप लोग का मल्टीप्लिकेशन ऑफ साइकिल. कैसे मल्टीप्लाई करेंगे? देखो, we multiply cycles by multiplying the permutations represented by them. For example, if the cycles 1, 2, 3 and 5, 6, 4, 1 represent permutations of degree 6 on 6 symbols 1, 2, 3, 4, 5, 6, then 1, 2, 3 एक cycle हो गया into 5, 6, 4, 1 एक cycle है. This is a cycle of length 3, this is of length 4. So it first can be written as 1, 2, 3, 2, 3, 1, 4, 4, 5, 5, 6, 6, another 5, 6. Another cycle 5, 6, 4, 1 is 5, 6, 6, 4, 1, 5, 2, 2, 3, 3. Now see here 1 goes to 2, but 2 goes to 2. So 1 will go to 2. Right here 1, 2, 3, 4, 5, 6. 2 goes to 3, 3 goes to 3. Right here 3. 3 goes to 1, 1 goes to 5. Right here 5. 4 goes to 4, 4 goes to 1. Right here 1. 5 goes to 5, 5 goes to 6. Right here 6. 6 goes to 6, and 6 goes to 4. Right here 4. So it is 1, 2, 3, 5, 6, 4. 1, 2, 3, 5, 6, 4. This is your cycle after multiplying these two cycles. since a cycle of length 1 represents the identity permutation, therefore 1 cycle of length 1 into cycle of length 3, 2, 3, 4 into cycle of length 1 is equal to 2, 3, 4 cycle of length 3, because this 1 and this 6 is they are identity permutations. इसके बाद एक और कॉन्सेप्ट है डिसजॉइंट साइकिल, और उसके बाद हम लोग थ्योरम पे आ जाएंगे. Two cycles are said to be disjoint if they have no symbols in common. कोई भी सिंबल उनमें कॉमन ना हो. फॉर एग्जाम्पल 135 साइकिल ऑफ लेंथ 3 एंड 2689 साइकिल ऑफ लेंथ 4, दे आर डिसजॉइंट साइकिल्स, क्योंकि इसमें इन दोनों में कोई भी एलिमेंट कॉमन नहीं. while 134 cycle of length 3 and 2356 they are not disjoint. क्यों? क्योंकि यहाँ पे 3 है, इधर भी 3 है. वन एलिमेंट इज कॉमन इन दोस टू साइकिल्स. तो आज के लिए इतना ही. रेस्ट हम लोग अगली क्लास में थ्योरम को देखेंगे. तब तब तक तुम लोग नोट कर लो. कोई अगर क्वेश्चन है तो पूछो मुझे.